On this topic here, it's actually anti-scale, if you will. It is down to the personal level. Rapid prototyping is super critical when it comes to design and development, early design and development, and trying to differentiate and so on and so forth. As an example, in automotive, and hence the topic. And the components in R&D in labs, if you will, that's the second very important component. That's actually a precursor, if you will, to design and development, especially in manufacturing. So, two sort of topics that are really close to my heart. And then I wish I had Excel Data Streamer back in the 90s when I was actually in automotive. So it kind of comes together. And as you bring in the Copilot with it, takes it to another level, right? And hence I thought, this would be an opportune time to talk about this, and really kind of David and Vesa to give me the opportunity.
Sanjiv, real quick, can you just throw that in the presentation mode? It looks better in the video. Just
wonderful,
real quick,
sir. Let me do that really quick. Is that good, sir?
Perfect. Yeah, excellent. Thank you so much. Yep.
Wonderful, So, like we talked about, enables development of rapid prototypes, ease of experimentation, especially in graduate labs. If you're an ME, EE, in any of the labs, do a lot of experimentation. And, at a bachelor's level, a lot of testing, classrooms, and so on and so forth. So Excel Data Stream is absolutely perfect for that. Bidirectional communication, you can control devices as well, get feedback from the devices over USB, so through serial ports. And then, you have the full benefit of Excel, live data visualization, integration with Excel functions, and now with, Python and Copilot inside of Excel, a lot of possibilities from a rapid prototyping and a R&D perspective. Now, got to call out the limitations. This is serial comms only, no native support for Wi-Fi, Bluetooth or MQTT. But then those are secondary to experimentation and to rapid prototyping, because those go on later when you're talking about productionizing things and so on and so forth. And then you kind of bring in the right protocols and so on, Azure IoT, and then like Mitunsha talked about, you can combine it with Power Platform, so on and so forth. The other important thing to call out is low data rate. Basically, you're talking about 100 hertz of sampling rate. Very important to keep in mind if you're doing high-speed testing or experimentation. So as an example, if you're doing ballistic armor and things like that, this is not the right tool for it because the rates are immense. You get into megahertz and so on and so forth. And then no native logs or automation. That's another call out. But those are all secondary. So with this, let us actually get in. I've got, let me just end the show. I'm going to go to my Teams, turn on my camera, and you should be able to see a Arduino board here. This is a tiny little guy, literally about 1/2 inch by 1/4 inch, lovely little board. And then it's got a built-in RGB LED here, right? I suppose everybody should be able to see it. It's got a built-in RGB LED. And then in Excel here, I've got my data streamer. So it's a add-in, you can download it. It's been there for quite some time, but people don't talk about it too much. And then I've gone in and actually connected through the serial port to my Arduino here, right? And the idea here is, in order to control the colors of, let us say this is a dash panel, and then I've connected the dash panel through Arduino to my Excel, and I'm in front of a customer and I'm actually doing rapid prototypes of the colors here, different colors, right? So I could basically go in and say, hey, look, turn it to, let's say, Prussian blue, or, let us say, pure red, if you will. And then if I were to go to my, it turns red, right? So the idea here is you're combining the chromaticity, if you will, of hue, saturation, and brightness that control. These are technical terms that are actually used in lighting within automotive. And you're basically controlling it using the Copilot function. So when I select pure red here, or when I say, hey, my mood is angry, or whatever it is, you can basically go in and ask the Copilot, hey, what does it mean from a hue standpoint when I say it is, I'm angry, or I'm in a meditative mood, or whatever it is. So you basically change these values and feed it, from your natural language. You get the values and you feed it to the cluster, and then you're sitting in front of the customer, and then you can do all these, sort of mood and, different design scenarios, if you will. early in the design phase, and I've actually done it with customers, right? But then it would take weeks for the simple reason you had to build the full prototype, so on and so forth, go in front of the customers. And now you can literally sit in front of them and, in a matter of days, get everything nailed down. So, a fantastic little tool to actually use, right? Now, this is from a rapid prototyping and automotive perspective. Likewise, you could do, hey, look, you can, from your Arduino here, let me make this a little bigger. Let me go to Teams maybe. So instead of actually an LED from this very board, you can connect it to a motor. And let us say the motor has a fan and there is vibration in it. You can actually bring the vibration over, do a fast Fourier transform inside of Excel, use the Copilot function in Python to actually do that, and then, do some modifications on getting rid of the vibrations and so on. So you could do it from a rapid prototyping perspective, right? Different industry in industrial applications. Now, this one here is an example of doing something similar in a lab. So as an example, I've got a ultrasonic sensor, and this merely is a metallic ruler. It's held at one end, and I just twang it. So when I twang it, it basically goes in and it actually vibrates, right? So this essentially is the solution to actually a second order differential equation that we guys in mechanical engineering have been beaten over the head, and that's where we get our scars, right? So essentially, without actually doing something and literally listening to it or seeing it in a mathematics textbook is very, very hard to visualize and to understand. And now you can cobble this so easily right on your desktop. I mean, this is literally at my place. And then you can get to see how the vibrations actually die down over a period of time. This is called as like damping and so on and so forth. And from here, you can actually get to see, if I move this along further, you can get to see what the frequency of vibration is. You can get the solution to your second order differential equation, so on and so forth, right? So the point here is, even from a experimentation, from a lab perspective, this is, probably in your bachelor's, maybe getting into graduate study. But then if you take it one step further, and let's say you're actually doing your PhDs and so on and so forth, you want to control equipment, instead of using some ugly code, you can actually use this and with Excel and do many, many things, right? And it's absolutely marvelous. And then that gives you, if you will, such an easy tool right in front of you, instead of having to struggle with, the many things that people actually struggle with, right? Especially for mechanical engineers and electrical engineers, so don't have, if you will, the wherewithal that maybe the CS guys have, right? So that's kind of the whole story, if you will, is combining, good old Excel with the data streamer, with your Copilot, to be able to do the many, many things that us mechanical engineers and electrical engineers actually do, right? So that, if you will, is the story. Quick little demo and a quick little video, and back to you, David. I trust this was useful. Thank you very much.